Good day, my viewers. Thanks for watching, and to my subscribers, I'm grateful. Thanks for subscribing to this channel. And if you are seeing this video for the first time, please, I advise, and I'm also begging for your subscription. In today's video, I want to teach velocity time graph, how to solve questions pertaining to what? Velocity what? Time graph. And of course, you know it's under motion, right? So right now, today, I always advise viewers, especially students or someone that wants to learn from this channel, to keep writing materials beside him or her. Get your pen and paper and get ready for today's tutorial. Good. Motion. Of course, you know what is motion, but like I said, my focus today is on what? Velocity what? Time graph. Now, graph gives accurate information on the motion of an object. I repeat, graph gives accurate information on the motion of an object. And there are three types of graph under motion. There are what? Three types of graph under motion. One, types of graph. One is what? Distance time graph. Distance what? Time graph. Two is what? Displacement time graph. Y3 is what? Velocity time graph. Did you understand? I said one is what? Distance time graph. Two is what? Displacement time graph. Three is what? Velocity what? Time graph. Now, I want to focus on velocity time graph for today. Velocity what? Velocity time graph. Maybe another day, on another tutorial, I'm going to teach distance time graph and displacement time graph. But why I am driving my focus to velocity time graph is because I have seen many questions on this, and this particular subtopic gives students concern. And it is should I say, the concept needs to be students need to understand the concept. So I want to unleash the concept today so that you understand it better. Now, velocity time graph is the most useful graph among the three graphs aforementioned. Among the most three graphs aforementioned. So, it gives accurate information on the motion of an object, and the information it gives are acceleration, one, acceleration, two, retardation. In brackets, another name for retardation is what? Deceleration. And of course, you know, deceleration is an opposite of what? Acceleration. Three, distance covered, or you say total distance traveled. Then IV, average speed. I repeat, velocity time graph is the most useful graph among the three graphs aforementioned, and velocity time graph gives accurate information on acceleration, retardation, distance covered or total distance traveled, and what? Average speed. So the information this particular graph gives to us, distance and displacement time graph don't do the same. They don't give us the same information. That is why I want us to focus on this for today. You get? So I'm going to solve many calculations on velocity time graph, and I'm going to teach how to solve calculations on velocity what? Time graph. That is why I'm soliciting for your subscription. If you are seeing this video for the first time, please subscribe so that you will get notification anytime I drop video like this. Now, there are many shapes formed on the graph. I mean on velocity time graphs. There are what? Many shapes formed on the graph. The shapes formed on the graphs are like one, shapes formed on velocity time graph are rectangle, triangle, or what we call right angle, triangle. But I believe you understood what I'm trying to say here. Then we have sphere. IV, we have trapezium, etc. etc. There are many shapes formed on the velocity time graph, and the shapes formed are rectangle, triangle, sphere, trapezium, etc. And the corresponding shapes gives information on the total distance traveled or covered. So to find the total distance traveled or covered, it is from the shape you are going to do what? Deduce that particular information. So you can never ascertain the distance traveled if you don't have the ability to understand the shapes formed on the velocity time graph. Now, let me quickly give you a breakdown of what I'm trying to say right now. Now look up. Let me give you an example of the calculation we have on the velocity time graph. Check your time. Let me do this over here. Can I? Okay, let me use here.